homologous series is a family of compounds with the same general formula, similar chemical properties. You may need to work out the general formula of families which have a functional group. And in today's lesson, we're going to look at working out the general formula for the carboxylic acids. The functional group which is found in carboxylic acids is known as the carboxyl group. And this can be identified by a C double bond O, OH. You can work out the general formula of a family by firstly identifying the functional group. In this case, we have the carboxyl group, and we want to keep that out of the molecular formula and put it on at the end. So we would have the molecular formula for the first one as CH3, COOH. Second one, C2H5, COOH. And for the third one, C3H7, COOH. When we stack up the molecular formula, we then want to use the trend of CnH2n, and we'll apply that in there. So for the first example, we've got one carbon atom. 1 times 2 is 2. How do we get to 3? We add 1. For the second example, we've got 2 carbons. 2 times 2 gives me 4. How would I get to 5? I would need to add 1. And for the third example, we've got 3 carbons. 3 times 2 gives me 6. How would I get to 7? I would add 1. So that means that the general formula for the carboxylic acids is CnH2n plus 1 COOH. Carboxylic acids are used in the preparation of preservatives, soaps and medicines. Vinegar is a solution of ethanoic acid with the molecular formula CH3COOH. Another property that we look at is the melting point and boiling point. As carboxylic acids increase in their size, melting and boiling points increase due to the increase in strength of the intermolecular forces between the molecules. So the examples that we've got here are methanoic, ethanoic and propanoic acid, and we can see that the melting points and boiling points are increasing. This is because they have more atoms in their molecules, therefore more electrons and more intermolecular forces between the molecules. For solubility, remember that this is the ability of a substance to dissolve in a solvent, in this case water. We have methanoic, ethanoic, propanoic and butanoic acid, which are miscible in water, meaning that they can dissolve readily. However, as we increase the carbon chain length from butanoic acid, so that's 5 carbons and above, the solubility decreases as the size of the molecule increases. This past paper questions from the National 5 2018 written 13A part 1. Malic acid is a carboxylic acid found in some fruits. Name the functional group circled in the diagram above. We can see that they've circled a C double bond O, OH, and this is known as the carboxyl group. This past paper question is from the National 5 2017 multiple choice 13. Vinegar is a solution of, remember this is one of the rote learned things that we have to know, that vinegar is a solution of ethanoic acid. This past paper questions from the National 5 2014 written 8B part 3. Ethanoic acid is the second member of a family of compounds which contain the carboxyl functional group. The full structural formulae for the first 3 members of this family are shown. Suggest the general formula for this family of compounds. So the first thing we have to do is we have to change this into the molecular formula, making sure that we keep out the carboxyl group separately, as this is a constant with each of the organic molecules. So once we've done this, we stack the molecular formula up and we do a trend with our CnH2n. So if we use the second and third one, if we look at ethanoic acid, we've got 1 carbon atom. 1 times 2 is equal to 2. How do I get to 3? I would add 1. 2 carbons, 2 times 2 is 4. How do I get to 5? I would add 1. So the general formula for this is CnH2n plus 1 COOH. We always add our functional group at the end. This past paper questions from the National 5 2017 written 7B part 2. Explain why butanoic acid has a higher melting point than propanoic acid. remember, when we're looking at this, we're looking at the number of atoms. Butanoic acid has more atoms, so therefore it's got more electrons, so therefore we'll have more intermolecular forces between the molecules, which have to be broken. This past paper questions from the National 5, 2018, written 13B. Describe how the acidity of the carboxylic acid is related to the position of the halogen in group 7 of the periodic table. So what factor are we in control of here? We're in control of the group 7 element. So the first thing I would do is use the data booklet to identify the positions. So I can see that it goes from fluorine down to chlorine, bromine and iodine. I would then look at the pH, which is given in the table, and put them in the correct order. So we can see 1.33, 1.42, 1.45 and 1.55 for the iodine on the carboxylic acid. So what we can see is as you go down group 7, that's the halogens, the pH increases, but the question doesn't actually ask us about the pH, it actually asks us about the acidity. And this means that the acidity of the acid decreases as the number gets closer to 7. This past paper questions from the National 5, 2022, multiple choice 12. Which of the following molecules will decolorize bromine solution and also form an acidic solution when added to water? So what we're looking at is the functional groups. For it to be acidic, I'm looking for a carboxylic acid. So I'm looking for a carboxyl group. So that could be A or it could be D. The other factor it wants me to do is to look at decolorizing. And we need to have a carbon-to-carbon double bond for an addition reaction to occur. So the correct answer to this is multiple choice answer D.